Gabrielle and on behalf of my collaborators, I'm presenting briefly today on 3 studies that we conducted looking at the disinfection of surfaces using locally available disinfectants. Now, surface disinfection is critical in outbreak contexts such as Ebola and COVID response, but evidence is limited on the efficacy of disinfectants and surfaces that are relevant to LMIC and humanitarian contexts. We polled an external technical advisory group about what they saw as the critical surface disinfection gaps from the field, and then they prioritized across low, medium, and high priority different factors in 3 areas, looking at different surfaces, disinfectants, and then surface disinfection conditions. Everything highlighted here in green is something that was included in one of our 3 studies. The first study we conducted was with Soapy Water. We looked at the exposure on either a stainless steel surface or in a suspension of the organism with and without soil load. We looked at 3 different organisms, SARS-CoV-2 virus, and then 2 bacteriophages, the enveloped Phi6 and the non-enveloped MS2. We applied a 0.5% soapy water as a disinfectant, and then we exposed the organisms for 1 to 20 minutes. Looking at our surface disinfection results, we can see that the SARS-CoV-2 here plotted in the black circles was decreased about half a log over the 20-minute contact with the soapy water solution. And that the MS2 was not impacted, so it was not efficacious against MS2, but we did have greater than 4 log reduction of Phi6 in 1 minute of exposure to the soapy water solution. Phi6 and MS2 trends held when we applied soapy water to a suspension of the organism instead of on a surface, but what we did observe was in suspension, SARS-CoV-2 was reduced greater than 4 LRV within 10 minutes of contact. Looking at our second study, we evaluated the efficacy of chlorine against Phi6, which is an enveloped bacteriophage that has been proposed as a surrogate for chlorine studies, proposed as a surrogate in chlorine studies for both Ebola and SARS-CoV-2. In this study, we utilized a variety of non-porous and porous surfaces to which a Phi6 matrix with and without soil load was applied. Those surfaces were then dried for 1 hour at one of 2 different relative humidities and 3 different temperatures. After that 1 hour of drying, a 0.5% NaOCl solution was applied to the surface for 1 to 5 minutes. Looking at the 23% relative humidity data here, what you'll observe is that we were able to recover Phi6 from almost all of our surfaces after 1 hour of drying. And then after exposing the surfaces to chlorine, we observed complete inactivation after 1 minute of exposure for all non-porous surfaces, but a decreased efficacy on those porous surfaces. You'll note that we still have recovered Phi6 at both 1 and 5 minutes of exposure, and wood in particular was challenging to disinfect. Similar trends for 85% relative humidity, where we had complete inactivation on almost all of our non-porous surfaces after exposure to chlorine solution, and decreased efficacy of the chlorine solution on porous surfaces. And then lastly, we looked at sunlight as a disinfectant. So we utilized 4 different surfaces with and without soil load. And we exposed these surfaces to one of 3 different natural sunlight conditions: full sun, partial sun, or cloudy. We used a non-exposed dark cabinet as our controls for comparison. And then we looked at 3 different organisms: Phi6 and MS2, again, the same 2 bacteriophages, and then E. coli as a bacteria. What we observed was that in natural sunlight conditions here in Boston, Massachusetts, in the USA, we were able to observe different solar radiation averages incident on those surfaces over the 3 days of exposure. And looking at results for the full sun condition, you'll note the purple bars are our non-exposed controls, the yellow bars are exposed controls. And for Phi6, that was the only organism where we achieved a greater than 4 log reduction, and that was only achieved in the full sun condition. The efficacy of sunlight as a disinfectant was decreased for MS2 and E. coli. And then just to briefly show the cloudy condition, for example, it was ineffective at reducing any 3 of the organisms that were tested. So some key takeaways are that disinfection efficacy is really context dependent. And from our first study, we recommend no change to WHO CDC protocols, which recommend using soap as a pre-cleaner and then applying a disinfectant. From the second study, we recommend 0.5% chlorine applied to surfaces with suspect contamination for at least 1 minute of contact. And from the third study, we recommend future evaluation of a full sunlight condition for 1 hour against the actual viruses for Ebola and SARS-CoV-2. With that, I want to acknowledge our funding from USAID's Bureau of Humanitarian Assistance and the work of our collaborators. Thank you.